Okay, so now I wanted to actually do this video tomorrow, but then I mean the basically I wanted to actually do question number 7 tomorrow, but it seems that it's not possible because question number 7 is related to question number 6, and if I want to do it tomorrow, then I'll have to again re-familiarize myself with the situation here, so it's not really worth it. So let's see what question number 7 is. It says that refer to question number 6, which is basically this whole situation here. This situation here. Refer to question number 6 above, state true or false, and give reasons for your answers. It must be, let's see what it is. It says that, for example, A and B are mutually exclusive. So, of course, A and B, you see A is getting an even number on the first dice, B is getting an odd number on the first dice, and of course they are mutually exclusive because there are no, these two sets have no outcomes in common, so they are mutually exclusive, meaning that A intersection B is actually equal to the null set, so they are mutually exclusive. Let me take a look at the answers over here as well as we go along. So okay, so of course this statement is of course true. The statement is of course true. You're supposed to also say whether the statement is true or false, which I didn't. Now the second part of this question is A and B are mutually exclusive and exhaustive. And of course that's also true, because you can see that getting an even number on the first dice and getting an odd number on the first dice, these we already established that they were mutually exclusive. Now, about being exhaustive, you need to basically just simply take the fact into consideration that over here you have either odd numbers or even numbers. So when you have accounted for the even numbers here and odd numbers here, then you have accounted for all the numbers here, which means that basically we said that if basically a number of events are exhaustive, they actually they account for all the possible outcomes of the situation or of the experiment, meaning that we said that the union of E of I, as I goes from 1 to n, was equal to the set S, which is the sample space. What that means is that if we have all of these events as, for example, E1 and E2 and E3 and all the way up to E of n, then this notation means that basically you take the union of all of those sets, meaning that E1 union E2 union E3 and union all the way up to E of n, that is equal to S. And if that's the case, that means that those events do basically those events do actually contain all the possible outcomes of the experiment. Otherwise, the union of them would not be equal to S, or to your sample space. So that's basically that. And as you can see over here, A and B are exhaustive. And if that's the case, basically, if this here is the case, we say that basically E1, basically these events, we call these exhaustive events, right? Now what happens is that, well, as you can see here, if you take the union of these two sets A and B, you will end up with, you will of course end up with S. So that means that A and B are exhaustive events. So number 2 is also true, which it is observed that basically A intersection B is equal to the null set, which we established here, and A union B is equal to S. Therefore, A and B are mutually exclusive and exhaustive. Thus, the given statement is true. Now, the third part of this question is A is equal to B prime. The question is A, or the statement basically, A is equal to B prime. So of course, B prime is the same thing as not B, and of course not B is, when B is getting an odd number on the first dice, then not B would be getting an even number on the first dice. And since that is the case, then B prime is, well, getting an even number on the first dice. Now, what is A? A is getting an even number on the first dice. So this statement is true. But to prove that logically as well, what you can say is that basically you do need to write out this set B prime, and then you can see that they are actually the same sets. So the third part of this question is, well, it is observed that B prime is equal to this set, which is equal to A. Thus, the given statement is true, which is basically how you do it logically, of course. The logic that I use is, well, if you understand the context and the situation, you can still use the context and situation to come up with these conclusions. But there is a problem there that you might actually make a logical mistake and things might go south. So you need to be careful there, of course. But usually, I mean, most of the time, like, I don't know, 90, I would say 99% of the time, if I'm saying something which is wrong, I usually know it. I usually know that I'm saying something, and I usually know that my logic is there is something wrong with my logic. Usually I don't make those kinds of mistakes. I do occasionally make mistakes in, for example, arithmetic and calculation and things like that. But when it comes to logic, when my logic is wrong, I usually know it. So, but of course, well, there is no excuse for not doing things right. The right way of solving this problem is this way. Is actually this way. So that the third part of this question is, we already did that. The fourth part of this question is A and C are mutually exclusive. A and C are mutually exclusive. So when we say mutually exclusive, that means that you have to show that the intersection of A and C is the null set. The intersection of A and C is the null set, which is, of course, well, over here you have all of these basically even numbers here, and of course you can see that, for example, 4, 1, for example, as just as a counter example, I can already see one member here that they have in common, so this is false. This is actually false, meaning that this statement is false. So number 4 is observed that A intersection C is not equal to the null set. Therefore, A and C are not mutually exclusive. Thus, the given statement is false. The fifth part of this question is A and B prime are mutually exclusive. So A is basically this set over here. We already know it. B prime is basically not B, and we established that not B was A. So now I'm left with basically two sets, A and A. And we are saying that A and A are mutually exclusive. Mutually exclusive meaning that the intersection of the two sets is supposed to be equal to the null set, which is not true. The intersection of A and A is actually equal to A. So the statement is false. So you can see that A intersection B prime is the same thing as A intersection A, which is equal to A. And so because A intersection B prime is not equal to the null set. Therefore, A and B prime are not mutually exclusive. Thus, the given statement is false. So I didn't understand this part. A intersection B prime is equal to A intersection A, which is equal to A. So basically then A intersection B prime is not equal to the null set, and so A and B prime are not mutually exclusive. Thus the given statement is of course false. Okay. Now there is this notation over here that we need to sometime later go and see what I know that this means this is usually used for the final conclusion of a series of logical statements, but this one, as I can remember, back in college they used this in India as because, but I don't really know, but I don't really understand how this has been used. Probably could be used in more than one way. So let's go and check what that is later. But so the next thing that we have is A prime, B prime, C prime are mutually exclusive and exhaustive. A prime, B prime, and C are mutually exclusive and exhaustive. Okay, so what we have here is, so when you have and here, That means that for this statement to be true, both parts have to be true, right? Meaning that this statement has actually two parts. The first part is basically A prime, B prime, and basically C are mutually exclusive. And also A prime, B prime, and C are exhaustive. Right? So if both of these statements are true, then this statement is true. Otherwise it's not, because you have an and here. So it's usually easy. It's usually enough to go with the simpler statement, and then if that's true, then you can go for the second statement, and then if both are true, then that means that your statement is true there. So now if I want to see if A prime, B prime, and C are mutually exclusive, so what that means is that then A prime is the same thing as not A, which is equal to B. So that means that this is B. So A prime is B, and B prime is the same thing as not B, which is the same thing as A, and C. So all that you need to know is really if A, B, and C are mutually exclusive, which is not the case, because of course A and B are mutually exclusive, because this is about even numbers, this is about odd numbers, but this is some mixture of some of these two. And so for example, you can see that 1, 1 is over here, so it's basically these are not mutually exclusive, meaning that they have to be pairwise mutually exclusive. For example, over here you can argue that A and B are mutually exclusive, but then C has to be mutually exclusive with B and also with A, which is of course, as you can see, not the case. With C and B are not mutually exclusive. So then the whole thing is false. The whole statement would be false, because to start with, this part is not true, and so it doesn't really matter if this part is true or false. If one part is false, the whole thing is false. So that means that it can be observed that A prime union B prime union C is equal to S. Okay, because A prime, we saw that basically these three were actually nothing but A, B, and C. And of course, if you take the union of those sets, you will get to S, because these are all subsets of S, of course. However, B prime union intersection with C is not equal to the null set, therefore events A prime and B prime and are not, I think this is, and C are not mutually exclusive and exhaustive, therefore the given statement is false. So this is A prime, B prime, and C are not mutually exclusive and exhaustive. Okay, so this was the example, the exercises here. The only thing that remains is here is what is that? Introduction to courses, commons, calculator. No. The only thing that we need here is just go and check for those logical notations, pairs of sets, word problems, cardinal, no. So math I don't even know what they are called. Probably math notation symbols. Somewhere over here. Let's see what these are. This is period mode. No, not this. These are geometry symbols. These are algebra symbols. These are linear algebra symbols. These are probability symbols. Combinatorics symbols. These are about permutation, combination, and factorial and that sort of thing. Set theory symbols. These are logic symbols. Must be over here. Yeah, you can see that this means therefore. This means therefore, and this means because. And there is a couple of things that are this means and, this means and, this means ampersand, this is also and, this is or, this is also or, this is vertical line means or, this is single quote, not negation, not negation, this is not negation, this is not negation, this is exclusive or, this is negation, this means implies, this means equivalent or if and only if, this is for all, this is there exists, this is there exists not, this is therefore, and this is because. So if you know basically this part, this much, it's usually enough. Of course, whatever sort of topic you learn in mathematics, the notation and the symbols and everything automatically come with it. But these are the things that you could basically take note of. For all, there exists not, and therefore and since. So I will write them over here just once, just for the sake of this discussion, and then we will basically. So this is basically, this means for all. This means for all. For example, if you want to say for all x belonging to the set of real numbers, for example. The way that you would write that, you would write it as for all x belonging to the set of real numbers. You see how basically compact and concise that notation is. That's for all. Then there exists is, this is there, this means there exists. This means there exists. This means there exists not. This means there exists not. Or basically there does not exist. There does not exist. And then this means therefore. This means therefore. And this thing over here means since or because. Okay, so these are useful things that you can always use when you write something and you don't want to use words, and when you don't want to use too many words to describe something, you can always use these, right? Okay, so that is that. So I think we are done here with these exercises, and then the next thing that we have is axiomatic approach to probability. So we will talk about that in the next video. See you in the next video, and thank you.